R is a free software programming language and software environment for statistical computing and graphics. The language is widely used among statisticians and data miners for developing statistical software and data analysis. Polls and surveys of data miners are showing R's popularity has increased substantially in recent years. R is an implementation of the S programming language combined with lexical scoping semantics inspired by Scheme. S was created by John Chambers while at Bell Labs. R was created by Ihaka and Robert Gentleman at the University of Auckland, New Zealand, and is currently developed by the R Development Core Team, of which Chambers is a member. R is named partly after the first names of the first two R authors and partly as a play on the name of S. R is a GNU project. The source code for the R software environment is written primarily in C, Fortran, and R is freely available under the GNU General Public License, and pre-compiled binary versions are provided for various operating systems. R uses a command line interface. However, several graphical user interfaces are available for use with R. Statistical features. R provides a wide variety of statistical and graphical techniques, including linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, and others. R is easily extensible through functions and extensions, and the R community is noted for its active contributions in terms of packages. There are some important differences, but much code written for S runs unaltered. Many of R's standard functions are written in R itself, which makes it easy for users to follow the algorithmic choices made. For computationally intensive tasks, C, C++, and Fortran code can be linked and called at runtime. Advanced users can write C, C++, Java, or Python code to manipulate R objects directly. R is highly extensible through the use of user-submitted packages for specific functions or specific areas of study. Due to its S heritage, R has stronger object-oriented programming facilities than most statistical computing languages. Extending R is also eased by its lexical scoping rules. Another strength of R is static graphics, which can produce publication-quality graphs, including mathematical symbols. Dynamic and interactive graphics are available through additional packages. R has its own LaTeX-like documentation format, which is used to supply comprehensive documentation, both online in a number of formats and in hard copy. Programming features. R is an interpreted language. Users typically access it through a command line interpreter. If a user types 2+2 at the R command prompt and presses enter, the computer replies with 4, as shown below. Like other similar languages such as APL and MATLAB, R supports matrix arithmetic. R's data structures include vectors, matrices, arrays, data frames and lists. R's extensible object system includes objects for regression models, time series and geospatial coordinates. The scalar data type was never a data structure of array. Scalar is represented as a vector with length 1 in R. R supports procedural programming with functions and, for some functions, object-oriented programming with generic functions. A generic function acts differently depending on the type of arguments passed to it. In other words, the generic function dispatches the function specific to that type of object. For example, R has a generic print function that can print almost every type of object in R with a simple print, object name, syntax. Although used mainly by statisticians and other practitioners requiring an environment for statistical computation and software development, R can also operate as a general matrix calculation toolbox with performance benchmarks comparable to GNU Octave or MATLAB. Examples. Example 1, the following examples illustrate the basic syntax of the language and use of the command line interface. In R, the widely preferred assignment operator is an arrow made from 2 characters, although equal can be used instead. Example 2, short R code calculating Mandelbrot set through the first 20 iterations of equation z equals za squared plus c plotted for different complex constants c. This example demonstrates use of community-developed external libraries, in this case CarTools package, handling of complex numbers, Multidimensional arrays of numbers used as basic data type, see variable c, z and x. Example 3, the ease of function creation by the user is one of the strengths of using our objects remain local to the function, which can be returned as any data type. Below is an example of the structure of a function. Packages. The capabilities of AR are extended through user-created packages, which allow specialized statistical techniques, graphical devices, import-export capabilities, reporting tools, etc. These packages are developed primarily in R, and sometimes in Java, C and Fortran. A core set of packages is included with the installation of R, with more than 5,800 additional packages and 120,000 functions available at the Comprehensive R Archive Network, Bioconductor, and other repositories. The Task Views page on the CRAN website lists a wide range of tasks to which R has been applied and for which packages are available. R has also been identified by the FDA as suitable for interpreting data from clinical research. Other R package resources include Cramtastic, a community site for rating and reviewing all CRAN packages, and RForge, a central platform for the collaborative development of R packages, R-related software, and projects. RForge also hosts many unpublished beta packages, and development versions of CRAN packages. The Bioconductor project provides R packages for the analysis of genomic data, such as Affymetrix and cDNA microarray object-oriented data handling and analysis tools, and has started to provide tools for analysis of data from next-generation high-throughput sequencing methods. Reproducible research and automated report generation can be accomplished with packages that support execution of a code embedded within LaTeX, Open Document Format and other markups. Milestones. The full list of changes is maintained in the news file at CRAN. Some highlights are listed below. Version 0.16 AA Euro. This is the last alpha version developed primarily by Ihaka and Gentleman. Much of the basic functionality from the White Book was implemented. The mailing lists commenced on April 1, 1997. Version 0.49 AA Euro April 23, 1997 AA Euro. This is the oldest available source release, and compiles on a limited number of Unix-like platforms. CRAN is started on this date, with 3 mirrors that initially hosted 12 packages. Alpha versions of R for Microsoft Windows and Mac OS are made available shortly after this version. Version 0.60 AA Euro December 5, 1997 AA Euro becomes an official part of the GNU project. The code is hosted and maintained on CVS. Version 1.0.0 AA Euro February 29, 2000 AA Euro considered by its developers stable enough for production use. Version 1.4.0 AA Euro S4 methods are introduced and the first version for Mac OS X is made available soon after. Version 2.0.0 AA Euro October 4, 2004 AA Euro introduced lazy loading, which enables fast loading of data with minimal expense of system memory. Version 2.1.0 AA Euro support for UTF-8 encoding, and the beginnings of internationalization and localization for different languages. Version 2.11.0 AA Euro April 22, 2010 AA Euro support for Windows 64-bit systems. Version 2.13.0 AA Euro April 14, 2011 AA Euro adding a new compiler function that allows speeding up functions by converting them to bytecode. Version 2.14.0 AA Euro October 31, 2011 AA Euro added mandatory namespaces for packages. Added a new parallel package. Version 2.15.0 AA Euro March 30, 2012 AA Euro new load balancing functions. Improved serialization speed for long vectors. Version 3.0.0 AA Euro April 3, 2013 AA Euro support for numeric index values 231 and larger on 64-bit systems. Interfaces, graphical user interfaces. Deducer Euro GUI for menu-driven data analysis. Java GUI for RA Euro cross-platform standalone R terminal and editor based on Java. Rattle GUI, a Euro cross-platform GUI based on RGTK2 and specifically designed for data mining. Commander, a Euro cross-platform menu-driven GUI based on TCL/TK. Revolution Analytics provides a Visual Studio-based IDE and has plans for web-based point-and-click interface. A GUI, a Euro comes with the pre-compiled version of for Microsoft Windows. RKWARD, a Euro extensible GUI and IDE for R. RStudio, a Euro cross-platform open-source IDE. RWECA, a Euro allows for the use of the data mining capabilities in WECA and statistical analysis in R. There is a special issue of the Journal of Statistical Software that discusses GUIs for R, editors and IDEs, text editors and integrated development environments with some support for R include Context, Eclipse, Emacs, LeX, Vim, JEdit, Kate, Revolution or Enterprise Developer, RStudio, Sublime Text, TextMate, WinEDT, TinR and Notepad++. Scripting languages. Our functionality has been made accessible from several scripting languages such as Python, Perl, Ruby, and F. PLR can be used alongside, or instead of, the PLPG-SQL scripting language in the PostgreSQL and Greenplum database management system. Scripting in R itself is possible via littler. User Conferences. User is the name given to the official annual gathering of R users. The first such event was User 2004 in May 2004, Vienna, Austria. After skipping 2005, the User Conference has been held annually, usually alternating between locations in Europe and North America. Subsequent conferences were, User 2006, Vienna, Austria, User 2007, Ames, Iowa, USA, User 2008, Dortmund, Germany, User 2009, Rennes, France, User 2010, Gaithersburg, Maryland, USA, User 2011, Coventry, United Kingdom, User 2012, Nashville, Tennessee, USA, User 2013, Albast, Spain, User 2014, Los Angeles, USA. Comparison with SAS, SPSS and Stata. The general consensus is that it compares well with other popular statistical packages, such as SAS, SPSS and Stata. In January 2009, the New York Times ran an article about gaining acceptance among data analysts and presenting a potential threat for the market share occupied by commercial statistical packages, such as SAS. Commercial support for R. In 2007, Revolution Analytics was founded to provide commercial support for Revolution R, its distribution of R, which also includes components developed by the company. Major additional components include Parallel R, the R Productivity Environment IDE, Revo Scale R, Revo Deploy R, Web Services Framework, and the ability for reading and writing data in the SAS file format. In October 2011, Oracle announced the Big Data Appliance, which integrates R, Apache Hadoop, Oracle Linux, and a NoSQL database with the Exadata hardware. Oracle R Enterprise is now one of two components of the Oracle Advanced Analytics option. IBM offers support for in-Hadoop execution of R, and provides a programming model for massively parallel in-database analytics in R. Other major commercial software systems supporting connections to or integration with R include JMP, Mathematica, MATLAB, Spotfire, SPSS, Statistica, Platforms Symphony, and SAS. TIBCO offers a runtime version or as a part of Spotfire. See also: List of statistical packages, comparison of statistical packages, list of numerical analysis software, comparison of numerical analysis software, Remetrics, programming with big data in R. References. External links. Official website of the R project, the R Wiki, a community wiki for R. R Books, has extensive list of R-related books, R Bloggers, a daily news site about R, with 10,000 plus articles, tutorials and case studies, contributed by over 450 R bloggers. The R Graphical Manual, a collection of R graphics from all R packages, and an index to all functions in all R packages, R Graph Gallery, an extensive collection of examples demonstrating the graphing and graphical design capabilities of R, many with source code, RSeek, a custom front-end to Google search engine, to assist in finding results related to the R language.